Hi, this is Kona, and we're going to go through solving for slope, y-intercept, test statistic, p-value, and all of that good stuff. So for the very first kind of example question, our summary statistics, we've got our variable, our n, which is the number in the sample, our mean, and the standard deviation. So enroll is just the number of extra hours the person has done enrolling in like above and beyond like professional development hours. So this would be enrollment in professional development hours. So this would be 300 is the average number of professional development hours. And salary is the mean salary. So for each person we found, so 36 people, for each person we found how many professional development hours they had done and what their salary was. And then this is the mean and standard deviation. The correlation coefficient, which is given, is 0.389, and a p-value is 0.0189. All right, so correlation coefficient, remember that's your R, and the p-value is given. So what type of correlation is this? Well, you might say, well, it's 0.389, that's positive, so it's positive. But what you need to look for before you could just say that it's positive, you have to look at that p-value. So if the p-value is less than or equal to 0.05, then you can actually look at the R value and determine whether it's positive or negative. So if the p-value was greater than 0.05, it would be none. But in this case, it's less than 0.05, so then you can look at the R value, that 0.389. That R value is positive, so this makes it a positive correlation. Should the calculated regression line be used for the estimation? Well, because that p-value is less than 0.05, we can say yes. The p-value is significant, so we can use it. So solving for slope, we take our R value, so that was our R right there, 0.389, times the standard deviation of y divided by the standard deviation of x to get the 23.30876,283. All right, solving for y, we then take this 23, this slope, and we plug it into this y-intercept, solving for the y-intercept. So the y-intercept is equal to the mean of y, so we've got our mean of y, the 49,347.25, minus our slope times our mean of x, which was a 300.36111115. So we calculate all of that out. We get our y-intercept, which is our 42,346.2041. So we take this and put it into our regression equation, our equation of the best fit line. So we take our slope, plug it in here. We take our y-intercept, plug it in there, and there you go. So our equation is 42,346.2041 plus 23.3087.6283. X is our regression equation. So that is the line of best fit. But something to consider, what if our p-value was actually 0.06? So what if up here, instead of our p-value being 0.0189, what if this was actually 0.06? If it was 0.06, then it's greater than 0.05, so there's no correlation. So we would actually circle none. And because it's greater than 0.05, the calculated regression line should not be used for the estimation. So you would not use the calculated regression line. Yet, let's say we want to go ahead and find that regression equation anyway. The slope, whenever there's no correlation because of this p-value, we know that our slope is 0 or close to 0. So when we go to enter that y-intercept, our y-intercept is just the 49,347 minus the 0 times our x value there, our x mean of the x, which basically 0 times anything is 0, which means our y-intercept is just the 49,347.25, which also means when you bring it down into that regression equation, because you're taking that slope again times the x value, our regression equation is just y hat is equal to the 49,347.25, which is why there's really no correlation going on there. So always look at the p-value. It's really important. If a p-value is given, you have to look at the p-value in order to know whether or not there's a correlation or whether or not you should be using the regression line. So finding the test statistic. So the test statistic is what we can actually use to find the p-value. So this was if we already had a p-value. So this is what if we want to find the test statistic. So it's find the t-value and the p-value. So in this case, we've got 14 pairs of values. The pairs of values, those are our n. So our n is 14. And a correlation coefficient, so an R of negative 0.57. So what's the value of the test statistic? So we just have our t is equal to negative 0.57 over square root of 1 minus negative 0.57 squared over 14 minus 2 is equal to negative 2.40135. If you're doing this in your calculator and you're not getting it to work, make sure you have the parentheses around the negative and that you have the squaring outside of that set of parentheses. In fact, you know what, hold on a second. Okay, so what I did, because I remember from previous semesters, a lot of people have problems with this, and I didn't record me entering it in just because you don't want to sit here and watch me do that. But this is exactly how you would enter this into your calculator. So notice the excessive use of parentheses. Yeah, it's pretty much insane the number of parentheses you have to include on here. So take note of all of the parentheses you need to include to get the correct answer. If you're getting the wrong answer, watch your parentheses, or if anything, you can go through and just do some of the smaller parts. So actually do the 14 minus 2, use the 12. You can do the 1 minus, or you can do the negative 0.57 squared, which remember will be a positive number, and then do 1 minus that number. So you can actually break this apart and do little pieces at a time if it helps you get the right answer. But if you're hardcore, you want to enter everything into your calculator at once, that's how you do it. That's where the number, the accurate, correct number comes from. So moving along, what is the two-tail p-value? So to find the two-tail p-value, we need the t and the degrees of freedom, which our degrees of freedom is n minus 2. So our t-value is just this right here, that negative 2.40, blah, blah, blah. Degrees of freedom is our n minus 2, where n was 14 minus 2, which is 12. And then we're going to enter this into the probability calculator. So, okay, so here's the probability distribution calculator. What we're going to do is click on student t. Our degrees of freedom are 12. Our t value is negative 2.4031530017. Do not round. And click calculate. Okay. It says the two-tailed p-value, so the two-tailed is the both sides, and we get 0.033326, which there it is right there, 0.033326. So to answer the next questions, what type of correlation is this? Well, first of all, is that p-value less than or equal to 0.05? It is less than 0.05, so then we would go back, look at our R. Our R value is negative, so we have a negative correlation. Should the calculated regression line be used for estimation? Yes, because our p-value is less than 0.05. All right, so moving along, we have 19 pairs of values that have correlation coefficient of 0.211. What is the value of the test statistic? So here's how you would enter it in. I went ahead and showed, like, if you wanted to go ahead, because remember I said you could either enter it all into the calculator with all of those parentheses, or you could start doing some of the math. So here's just an example of what it would look like. But ultimately, you'll get that t value right there. And then we will pull that up. This is so aggravating. Sorry, for some reason, my computer, it I don't know. It's really aggravating though, because as soon as I do this, it goes away. But there we go. Okay, so this time degrees of freedom is 19 minus 2, which is 17. Our t value is 0.8900129848. Click calculate, and both sides is 0.385881, which 0.385881. There we go. So what type of correlation is this? Well, we look at our p-value. Our p-value is 0.38, which is greater than 0.05, so it's none. So it doesn't even matter, even though this technically is a positive correlation. Technically it isn't, because our p-value is greater than 0.05, so it's a none. And should the calculated regression line be used for estimation? No, because our p is greater than 0.05. So there you go. We just worked through some problems. This should help with the quiz and hopefully help with your understanding of regression and correlation.